All right, let's take a look at your opener to 6.5 today. It says, are your following two triangles similar? So right now when I'm looking at them, right now I got the 48 degrees with the 48 degrees, but I don't have a way to tell if there's any other angles that are congruent here. There are no vertical angles, there's no parallel lines, they're not sharing an angle. So instead we have to go and look at the sides, right? And what we know about the sides is they're going to have to reduce to the same thing, right? When we look at these then, please keep in mind, just because something's on the left does not mean it has to match with something's on the left or the bottom with the bottom. The way we're going to tell what sides have to match up is you need to do the big with the big. Well, my biggest sides are the 13.5 and the 4.5. If you go to reduce 13.5 over 4.5, we get 3 over 1. Likewise, we can do the medium with the medium. That would be 9 over 3. That also reduces to 3 over 1. So far, so good. And then the last one then would be my 7.8 over my 2.6. 7.8 over 2.6 does also reduce to 3 over 1. Right, so all three sets of sides reduce to the same thing. What we're going to go over at the start of class today is, without my angles, that is already going to be enough for us. Right, our second shortcut is your side-side-side similarity theorem. And all it says is that if all three sets of sides reduce to the same value, if they are all what they call proportional, then the triangles are similar. Right? So we're looking at that AB over RS, BC over ST, CA over TR. We're looking at those ratios need to be the same. And the way you tell which ones you do is you do big with big, medium with medium, and small with small. So let's take a look at your first one here. It says, is either triangle DEF or GHJ similar to triangle ABC? So let's start with DEF, comparing it to ABC. So we're looking at big over big. That would be 8 over 12. 8 over 12 reduces to 2/3. Medium over medium, that would be 6 over 9. 6 over 9 reduces to, we got 2/3 again. So far, so good. Right? Small over small would be 4 over 8. 4 over 8 reduces to 1/2. Since all three did not reduce to the same thing, my answer is no. Now it says, is either triangle DEF or triangle GHJ similar to triangle ABC? So let's try GHJ. Is it similar to ABC? So once again, we'll do big over big. We're looking at 24 over 12. Reduces to 2 over 1. Medium over medium would be 18 over 9. Reduces to 2 over 1. Small over small would be 16 over 8. Reduces to 2 over 1. Since all three reduce to the same thing, triangle GHJ is similar to triangle ABC. All right, and the second one says, find the value of x that makes triangle ABC similar to triangle DEF. So once again, now we're not going to be able to tell what makes the small side, what's the medium side, what's the big side, because it would all depend on what x is. Right? For example, if x is 10, AB becomes the medium side. But if x is 5, AB becomes the small side. So we can't do it that way, so they have to give us some other way to tell. And here's where our similarity statement comes into play. It is AB, x minus 3, over DF. I'm sorry, AB over DE, which is 20, because they go first to second and first to second. It is BC, which was second to third, and EF, which was second to third. So it is 4 over 10. And then it is AC, which was first to third, with DF, which is first to third. So that is 10 and 2x plus 3. These three ratios all have to be equal to each other for these triangles to be similar. So you get to pick any two that you want and set them equal to each other. My advice, make it easy on yourself. Either do the left in the middle or the right in the middle. Either way will work. I would not do the left and the right because you're going to end up having to FOIL and factor. You'll get the right answer. It's just going to be a lot harder. So if we do the x minus 3 over 20 equals 4 over 10. When we cross multiply, 20 times 4 is 80. The 10 times the x minus 3 is 10x minus 30. So we add 30 to each side. We get 110 equals 10x. And then we'll divide by 10. And we get x to equal 11. All they want us to do is find that value of x that works. X is 11. So that's the way SSS or side, side, side works. Our last shortcut is known as side angle side. Which, as you remember, the angle must be in between our two sides. The angles have to be congruent to each other, and the sides have to be what we call proportional. So if I'm looking at my picture here, angle X is congruent to angle M, and then those ratios have to be the same. ZX over PM will have to be the same as XY over MN. So if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, meaning the sides that make the angles have to reduce to the same thing, then the triangles are similar. Let's look at our example. It says, Mrs. Kovic is drawing a design for a bird feeder. Can't you construct the top so it is similar to the bottom using the angle measure and lengths that are shown? So my three choices we've gone over are angle, angle. So do we know two angles in each triangle? No, we do not. We only know one. Side, side, side means I'd have to know all three lengths of my sides, which we do not. So side, side, side is out. Or side, angle, side, meaning the angle must be congruent. I got the 87 degrees with the 87 degrees. And then the ratio of the sides have to be the same. So 32 over 20. And it just so happens in this problem, I made it nice and easy for you. It's a 32 over 20 on the other side also. Right? That is what SAS is going to look like. They don't have to be identical. They just would have to reduce to the same thing. So it's 8 over 5 and 8 over 5 as far as what they would reduce to. So we have three different similarity postulates. The first one was angle, angle. Two angles from each triangle are congruent. We had side, side, side. The ratios of your three sets of sides reduce to the same thing. We call that being proportional. And then combining the two was your side, angle, side. Two sets of sides are proportional, and then that included angle in each triangle is the same. Right, so those are your three options that are there. Once again, if you need to pause the video to copy something down, please do so. Then we look at our last example. It says, choose the best triangle similarity postulate or theorem to answer the following, and then prove them to be similar. All right, going through our list, angle, angle. Do we have any sets of angles being congruent? we have our vertical angles. Angle PRQ is congruent to angle SRT. So there's one set. But unfortunately, we don't have your parallel lines, or they don't share an angle. We don't know the measurements of anything else, so we only have the one set. For side, 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 I need to know all three sets of sides, but we do not. So that leaves us with side angle side. We have the angle already. We have to look at our sides. And remember, we match big with big, small with small. So 18 would get matched up with 24. 9 would get matched up with 12. 18 over 24 reduces to 3 over 4. 9 over 12 also reduces to 3 over 4. So we have our two sets of sides reducing to the same thing. So are they similar? Yes, they are. Why? Because of SAS. Right? And then you see your homework is right here. Then we'll talk about when our chapter test will be during class.